Hello all. Okay, so as x approaches infinity and you have a fraction equation, then you think about your exponent rules for horizontal asymptotes. So if we look at our highest exponent, on top we see a 7, on bottom we see a 6. So that means the top is larger than the bottom. The smaller exponent is on bottom. So that's when we have to ask ourselves, do we have a y equals 0 asymptote, or do we have a number, or is there none? So for us, since we have a larger exponent on top than on the bottom, there's no horizontal asymptote. Well, darn. This says if no horizontal asymptote exists, then we have to plug in the x, what x approaches, into the leading terms. So the leading terms is the same as the leading coefficient. So the leading term is attached to whatever has the highest exponent. So the term that has the highest exponent is this 42x6 and this 15x6. So what we're going to do is we're going to plug in this x approaches negative infinity. So 42 something to the 7th over 15 something to the 6th. And we don't care about this last stuff. We only care about the junk with the highest exponents. And then I'm going to plug in a negative infinity here. Okay, and you might be thinking, how do I do that? Well, we don't really. We just think about the signs, because if you raise infinity to itself, you know, infinity times infinity, it's still infinity. But we have to think about the signs. So that's where step 3 comes in. If you have a negative number raised to an even power, or a negative infinity raised to an even power, like on this bottom, it's going to spit out a positive. Whereas on the top, we have an odd power. That's 7, so it spits out a negative. So if I were to say negative infinity to the 7th, multiplied with 42, it would still be a freakishly large infinity, but it would be negative. So that's what I care about, the negative or the positive. Then step 4 says divide those signs and slap an infinity on it. Okay, what's a negative divided by a positive? It's a negative. And then slap an infinity on it. Bam. What? That seems like I just pulled that out of the air, but it's a real thing, believe it or not. Okay, now let's go over how to find vertical asymptotes. You look at the bottoms only, and you factor, and you solve them for x by equaling to 0. So for vertical asymptotes, we only look at the bottom, the bottom, the bottom, the bottom. Yeah, okay. And there's a typo on this last sucker. It's supposed to be x squared plus 9. X squared plus 9. Okay, so we are going to factor the bottoms and equal them to 0. And I only put the kinds that are on your homework. Okay, so let's take this denominator out. Negative 4x plus 4. E. Okay, and then we're going to factor it. So on this one, there is a GCF. The GCF is definitely a 4 because both of these have a 4 on it. So let's see what happens. I'm going to write down 4, open parentheses. What do I have to put inside these parentheses so that when I multiply it back out, I get negative 4x plus 4. Or what multiplies with 4 to give you negative 4x? Well, definitely a negative and an x. That way, 4 multiplied negative x is negative 4x. Okay, now, what multiplies with this 4 to give you 4? Nothing but my good friend Juan, and he's positive. Okay, so we just factored. Now we're going to equal each thing to 0. So 4 equals 0, negative x plus 1 equals 0. Okay, well this one on the left ends up being trash because we cannot solve for x if there's not an x here, and I just have a 4 and a 0. That's not an x, so that gets trashed out. For this sucker, let's try and get x by itself. I think I'm just gonna pick up that negative x and plus him to the other side. That might be easier for me. And I get 1 equals x. Hey baby, that's your vertical asymptote. So if I were to graph this sucker in my calculator, either using this alpha y equals or parentheses around the top and the bottom, either way, I should get a vertical asymptote when I go to look at my picture at x equals 1. So let's go to my picture. Oh, and look, it looks like there's a pretend imaginary line that these curves don't touch. That's a vertical asymptote. And look, it's at x equals 1. Another way I can tell where the vertical asymptote is I can go to the table. I can press second graph, and whenever x is 1, we should have an error, because that means there's nothing that exists there on the graph. It's an asymptote. So wherever you see error, it's more than likely it's the vertical asymptote. Okay, let's try this next sucker. X minus 2 times 5x squared plus 5x. Okay, so first we're going to take out the denominator, which is 5x squared plus 5x. Then we're going to try and think of a GCF. So I think my GCF is definitely a 5, because there's a 5 on both of these. And I think I'm going to go ahead and put an x on my GCF, because there's an x on both of these. So I'm going to write 5x, open parentheses. Now let's think to ourselves, what multiplies with this 5x to give me the original problem? 5x squared, well, let's see, 5x and 5x squared. The way I get from one to the other is I multiply by an x. Then the way I get from 5x to the 5x I had is you multiply by 1. So let's see here. 5x multiply x, 5x squared. 5x multiplied by 1, 5x. Okay, then we're going to equal each of these to 0 and solve for x. So over here on this first one, when I divide by 5, I get x equals 0. You might be thinking, what the heck? You threw that in the trash on the last problem. On the last problem, I threw it in the trash because there was no x in my GCF. There was no x, so I threw it in the trash. This one, there's an x, it's right there. Okay, so this is one of my vertical asymptotes, x equals 0. Then we should have another one at, let's see, when I subtract 1, I get x equals negative 1. So I should have 2 vertical asymptotes. So if I were to graph this, I should end up having 2 errors in my table. 1 error at 0 and 1 error at negative 1. Let's see. So I'm going to press second graph, and I should have an error at 0 and negative 1. And I do. Yeah. Okay. If I go to my graph, I should have an up and down boundary at negative 1 and 0. Let's go to my graph. Here it is. Okay. And you can't really tell. Maybe let me zoom in number 2 and then press enter. And here you can really see it. Here at negative 1, there's an asymptote. And here at 0, there's an asymptote. Because if you look, your curves get really close to them, but they never cross them. Okay, let's look at this bottom right sucker. It says x squared plus, nope, x squared minus 9. So first we're going to take out that denominator, x squared minus 9. We're going to factor it. This is a difference of two squares where it's the same thing multiplied by each other. We know it's a difference of squares because there's a minus and a tiny 2. And there's only two terms. Okay, so I'm going to write a minus and a plus. And then what times what multiplies to x squared? It has to be the same thing. So x and x. Then you ask yourself, what times what gives you 9? It has to be the same thing. 9 and 1? No, it has to be the same thing. 3 and 3. Okay, now we're going to equal these to 0. And solve for x. And I think we get 3 and negative 3. And you can write them like this with a comma in between, or you can write them separately. I think your homework wants them with a comma in between. Okay, this last example, I told you there was a typo. There was a plus sign. There's a reason I did that. On your homework, you will have something like this where there's a squared and a plus, and it's called a sum of squares. So I'm going to take out this denominator, x squared plus 9. But then I cannot factor it because it's a sum of two squares. So I cannot do this thing where I split it into, you know, two pieces that multiply together, because nothing multiplies to this. You might think it does, but check yourself. You're wrong. Okay, so this is called a sum of squares, and sums of squares cannot factor. So when it cannot factor, you say there's no vertical asymptotes. And I guarantee you, if we looked at the picture, there would not be a vertical asymptote.